Welcome you all for the video lecture on evolution of operating system. The primary reason for OS evolution is listed in this slide. The OS may evolve whenever the hardware upgradation happens or a new type of hardware is being introduced in the market. And also, if any new services is demanded by the user and to fix any holes in the OS, the major OS evolution will happen. This diagram shows the major stages of OS evolution. It starts from serial processing, then step into batch processing system, then multi-programmed batch operating system, finally time sharing system, which we will be discussing in detail. The first computer system was introduced in the year 1940 without any operating system. In later 1950, the first operating system called as GMAS, that is General Motor Operating System, mainly for IBM machines, was introduced. In 1960, simple batch processing operating system concept was introduced. In 1970, the multi-programming operating system and time sharing concepts have been introduced in the operating system. In 1980s, the operating system for personal computers, multiprocessor system, and networked or distributed systems was being introduced. While in 1990s, the web-based system operating system was introduced. Now we will see all the evolution one by one. We can divide the evolution into seven major phases. Each phase we will be discussing in detail in our further slides. Let me move to the in 1940, the first computer system was introduced, but there was no operating system at all in that period. The jobs were run as an open shop. Here, the user will come and sign up in the register for certain time to use the computer. So, major drawback during this period was the since the users are reserved the time to utilize the CPU. Suppose assume that the user have completed his task before the stipulated time. For example, assume that he reserved for 1 hour time, but he could able to complete by half an hour. So the other half an hour time, the resource, the computer will be idle because the next user reserved uh, after that this first user. So since he completed before his stipulated time, the remaining time will be wasted. So this is the drawback during this period. In order to overcome this drawback, batch processing system was introduced. In 1950, the batch processing operating system concept was introduced in order to overcome the drawback we experienced in the previous method. Here, the user has no longer access to the machine. They'll be coming and submitting jobs to the operator who will batch the similar jobs together, and he will execute jobs batch by batch in order to save the time. The jobs of similar nature which are bundled together so that the efficiency will be improvised. So in batch processing system, there is a special code called monitor which takes care of monitoring input and output of the jobs. In 1970, the multi-programming concept was introduced in operating system in order to increase the CPU utilization. The operating system was trying to keep several jobs in memory in order to increase the throughput, that is CPU utilization. This is based on the concept that the job will move into several stages before completing its operation. For example, it may use CPU to execute some instruction. It may use some IO devices to perform some IO related operations and all those things. So it will be moving into different stages. I mean, it will use different resources. While it is using other resource, the next resource which is idle will be utilized effectively by the operating system. This is the core concept behind multi-programming operating. The first diagram corresponds to uniprogramming, means that only one program will run at a time. The program A, which is in run state, means that it uses CPU to complete its operation. Later, it will move into wait state, means that it uses IO device to complete its operation. For example, let us assume like that. After completing that IO operation, again it utilize the CPU to complete its operation. So before completing the entire operation, it will move to run and wait state alternatively. The second diagram corresponds to multiprogramming. In here in multiprogramming, first we have chosen two programs for simplicity, right? The program A initially put in run state. It means that it uses CPU to execute its instruction. Afterwards, it enter into wait state. It means that it release the CPU. Now the CPU is idle. During this time, the CPU may be assigned to one of the process waiting to utilize the CPU. This is the concept behind multi-programming. Now, program B initially, which is in wait state, will be allotted CPU, so that while program A is waiting for some IO completion, the CPU which is idle during that time will be assigned to the next program which is waiting in the queue. So program B will be assigned the CPU. Hence, it is shown as run state. Now program B is running. So after completing its CPU execution, the program B releases a CPU. Now program B enter into the wait state. Now here for simplicity we have chosen only two programs, but in reality multiple programs will be run in this manner to improvise the CPU utilization, that is to increase the CPU throughput. So the main concept behind the multi-programming is, while one program is using it IO devices, while one program perform it IO operation, the other program which is waiting in the queue will go and occupy the CPU to complete its operation. The major drawback experienced in multi-programming operating system is, if the longer program occupies the CPU, then the shorter program which is waiting in the queue have to wait for longer time. So it means that the shorter program will suffer by starvation. In order to overcome this difficulty, time sharing system was introduced in the year 1970. Here, each process which is waiting for the C processor will give an equal opportunity. I mean, they'll be treated with equal priority. So we can say that this is the logical extension of multi-programming. Every user gets some dedicated amount of CPU time to complete its operation. Hence, CPU executes multiple jobs by switching among them. Here, tasks no longer have to wait for previous tasks to finish to get the processor. Once the time slice is expired, automatically the CPU will be allotted to the next process which is waiting in the queue. So this is mainly to avoid starvation which was experienced in multi-programming operating system. Personal computers was introduced in the year 1980. They are a single user system and they are portable. Since they are used by a single person, there was no need of any advanced CPU utilization or protection feature. But the additional feature which was required by the personal computers or file protection. So the operating system was evolved with the file protection to support personal computers. Multiprocessor system, or also called as parallel system, which was introduced in the same year 1980. This is mainly to support when the computer system comes with more number of cores. Right, in order to if use this core effectively, the multiprocessor operating system concept was introduced to improvise the throughput and reliability. Um, we can say that this is fault tolerant. It means failure of one of the processor will slow down the system, but it will not halt the system. This is known as graceful degradation. This multiprocessor system are divided into two. One is loosely coupled, the other one is tightly coupled system. And the processors which share the memory and a clock are called as tightly coupled, where if they have their individual resources, they are called as different categories of multiprocessor system. One is symmetric and asymmetric. In symmetric multiprocessing system, identical copy of OS will be running in all the processor, whereas in asymmetric will have their own specific OS. In distributed system, the computations are distributed with several processes which are present in scattered locations. We can say that they are loosely coupled or tightly coupled based on how the resources are allotted to them. Each processor, if they have individual own local memory, then they are called as loosely coupled. If they are going to share some common set of resources, then they are called tightly coupled. The main advantage of this distributed system is resource sharing, load sharing, reliability, when all those things. Finally, the real-time system. This real-time systems are used to control device, mainly specifically dedicated for some application. For example, assume that in a industry, some dedicated system is monitoring the boiler temperature or pressure. Whenever the pressure or temperature exceeds some threshold, immediately give an alarm to the concerned person. So this is an example for real-time system, which it means that that system is employed for some real-time application. So here we can classify the real-time system into two. One is hard real-time system and the other one is soft real-time system. The hard real-time systems are nothing but systems which are employed in some employed for some critical task. The example I said, that is the system which monitors the boiler temperature or pressure, is an example for hard real-time system. They are, because they are monitoring the critical task. Whereas soft real-time system, it means that the real-time task gets priority over other tasks and retains that priority until it completes, but it is not a not for some critical assignment. The handheld devices, uh, the operating system which is used in a handheld device must take care of the slow processor and limited memory available for the handheld devices, and the small display screens and all. These are the main considerations taken into account while developing the operating system for handheld devices. Thank you all for watching the video.